The diagram shows r is equal to 1 plus 2 sine theta. So this is this curve here, including the inner loop here. And we're asked to find the shaded area of the inner loop of the limacon. This is the name of the curve. So we need to find this shaded region here. So to find the area for a polar equation, the area is going to be from alpha to beta over half r squared d theta. So if we look closely at the diagram, here is theta is equal to 0, pi by 2, and pi. And then if we go around the other way, minus pi by 2, and then minus pi. But you can go around and do 0 to 2 pi. However, the first angle here, this angle here, and if you think about it, if you're measuring from here, would be minus 5 pi over 6. So if you think about it, if you're measuring the negative angle from here, and this angle here would be minus pi by 6, okay? Now if you want to, you can add 2 pi to each of those and use positive values. Okay, so the integral is going to be the half from minus 5 pi by 6 to pi by 6 of r, which is 1 plus 2 sine theta squared d theta. Okay, writing that out again. Like I said, you could use positive values by adding 2 pi's to these if you prefer. Right, so it's going to be a half of minus 5 pi 6 to minus 5 pi 6. And if we expand this, we get 1 plus 4 sine theta plus 4 sine squared theta d theta. We can integrate this, but this is a bit more challenging. But there's a standard result. We know that cos 2a is 2 sine squared theta, 2 sine squared a minus 1, sorry. Let's just get our notations right. So that means that sine squared a is going to be a half brackets 1 minus cos 2a. This is sort of a standard result which you should really learn, which we'll replace in here. So we're going to get a half of 1 plus 4 sine theta plus, now 4 over 2 is 2, so we're going to have 2 minus 2 cos 2 theta d theta. Just going to put these two together, so we're going to have a half from minus 5 over 6 to pi over 6 of 3, 1 plus 2, 4 sine theta, 2 cos 2 theta d theta. So notice I spent quite a bit of time preparing the integral before I've actually integrated. Right, now to integrate, so it's going to be a half of 3x. If you integrate sine, you get minus cos, so it's minus 4 cos theta. And if you integrate minus cos, you're going to get minus sine. Now, it's sine 2 theta, okay, because if I differentiate that back, that 2 will go in the front, and I get cos 2 theta, exactly what I want. Now, the limits now go at the end here. So minus 5 pi by 6 and pi by 6. Just write that out again, sorry. There we go. Please make sure you're trying to use the correct notation. Right, now you need to be really, really careful when you substitute in and do quite a few steps rather than trying to jump straight to the answer. So we've got a half of brackets of 3 times minus pi by 6, minus 4 cos minus pi by 6, minus sine minus pi by 3, minus 3 times minus 5 pi 6, minus 4 cos minus 5 pi by 6, and when we multiply this one by 2, we get sine of minus 5 pi over 3. Notice here, when we multiply this by 2, we get 2 pi minus 2 pi by 6, which is minus pi by 3. Right, so it's going to give me a half of 3 times minus pi by 6, which is minus pi by 2. Now, minus pi by 6 is in the fourth quadrant, so cos is positive, and cos of pi by 6 is root 3 over 2. So this will be minus 4 times root 3 over 2. This will be this bit will become positive. Minus pi by 6 is in the fourth quadrant, but sine is negative in the fourth quadrant, so it's minus root 3 over 2. This is where you need to be careful. Keep that minus sign out and keep the bracket in. So we're going to get 3 divided by 6, which gives me a half, so we're going to get minus 5 pi by 2. Again, this is now minus 5 pi by 6 is in the third quadrant and cos is negative, so we're going to get minus 4 minus root 3 over 2. This is a difficult one. Minus 5 pi by 3 is actually in the first quadrant, and so therefore sine is positive in the first quadrant, and therefore it's the same as doing sine of 60, which is root 3 over 2. Right. Still haven't taken the half in, so I'm just going to go through and try and remove this bracket, because otherwise I'm going to make a mistake if I'm not careful. So I've got minus pi by 2 minus 4 pi, minus 2 root 3, because 4 divided by 2 becomes 2 root 3, plus root 3 over 2, minus makes plus 5 pi by 2, minus times a minus makes a plus, times a minus makes a minus, and that becomes the 4 and the 2 cancel out, so we get minus 2 root 3, and then minus with a minus will make plus root 3 over 2. Okay, minus pi by 2 and 5 pi by 2 will become 2 pi. I've still got that half out the front. Minus 2 root 3 minus 2 root 3 will make minus 4 root 3, and plus root 3 over 2 plus root 3 over 2 will make root 3. The last step will be to just add these together here, so we get a half of 2 pi minus 3 root 3 square units. Okay, so it's quite complicated substitution there at the end. You need to take your time and be careful with the signs, putting minus ones into brackets, okay? Otherwise you're going to make a mistake if you have to show detailed reasoning. Okay, so it's been a video to show you how to find the area of the inner circle of a lemison. I hope you've understood, and I thank you very much for watching.